Good morning, sir.
Good morning, beta. Good morning. Good morning, everyone.
Good morning, sir. Good morning.
Good
Good morning,
morning.
sir.
Good morning. Okay, so were you able to complete the assignment, beta?
नहीं सर
Yes, sir.
असाइनमेंट
Number two
नहीं
हो
हुआ
गया
सर.
sir.
Okay, beta. All right. Okay, great. So, up beta, after this, the next topic which we have, there are a couple of small topics coming up now. First is 3-point bearing or three bearings of the same object. So the name looks familiar?
Yes, sir.
Yes, sir.
Right. So you have done this in second mates also. So we will be doing it now. That is the 3-point bearing. And after that, we have a technique in chart work which says sighting a object right ahead at a certain distance. So there is some current in the area. You have to steer a particular course that a object comes right ahead of you at a given distance. So we will discuss that method. And then after this, the next one which we have is what we call as blind navigation. Blind navigation is navigation in restricted visibility. So these are the topics which are coming up. So one by one, let us see these topics now. So first we move into 3-point bearing. So we will understand what this technique is, what information is given, and how do we plot it. So shall we go into the presentation beta?
Yes sir, sure sir.
Yes, sir.
Okay. Let's move on to our next topic now, which is 3-point bearing. This is also known as three bearings of the same object. Let's first of all see what all data, what all information is provided to us, is given to us in these kind of questions. We are given three bearings of a particular object, of the same object. The time of all the three observations is also provided in the question. Now we are also given any three items out of the course steered by the ship, engine speed of the ship, set and rate of the current. So out of these four items, any three items are provided to us in this particular question. What we are required to find out is the course made good and also the positions of the ship at all the three times of observation. Now let's try to understand this concept using a practical question by solving a practical question on the chart.
सर
Go ahead, beta.
सर एक बार लास्ट स्लाइड दिखाएंगे प्लीज और डाटा गिवन इन द 3-point bearing.
Okay, beta. Okay, let me show you. Here it is.
Okay sir, thank you.
Okay. So let's move ahead. Now let's try to understand this concept using a practical question by solving a practical question on the chart. We have the question on the screen now. A vessel steering 070 degrees true at a engine speed of 10 knots observes the bearing of hook headlight as 035 degrees true at 1000 hours, 000 degrees true at 1032 hours, and 315 degrees true at 1100 hours. The current in the area was observed to set 105 degrees true. Find the position of the ship at the time of all three observations: the course made good, the speed made good, and the rate of the current. So we can see that we are given three bearings of the same object, hook head lighthouse, and we are required to find out the course made good, speed made good, rate of the current, and all the three positions. Beta, any doubt in the question? Is it clear?
Yes, sir.
Yes, sir, clear.
Okay, beta. All right. So let's first identify the landmark. We have the hook head light at this particular location. Now let's first plot the three given bearings. Let's mark the hook head lighthouse as O. The first bearing which is given to us is 035, and this bearing was taken at 1000 hours. Let's mark this bearing as OX. So we can see the bearing on the chart, OX. The time is mentioned along with the bearing line, and the value, the bearing of the object, the lighthouse, hook head lighthouse 035 is also mentioned. The second bearing was taken at 1032 hours. The bearing was 000, and let's mark this bearing line as OY. So we have the second bearing line on the chart. The time is mentioned here as 1032. The bearing is also mentioned as 000. The third bearing was taken at 1100 hours. The bearing was 315. So we have plotted this third bearing on the chart, and let's name this bearing as OZ. Now in the next step, we have to calculate the ratio of the two time intervals between first and second bearing, that is OX and OY, and between second and third bearing, that is OY and OZ. I repeat, we have to calculate the ratio of the two time intervals between first and second bearing, that is OX and OY, and second and third bearing, that is OY and OZ. Now in our case, the time interval between first and second bearing, that is 1000 and 1032, the time interval is 32 minutes. And the time interval between second and third bearing, which is 1032 and 1100 hours, is 28 minutes. So 32 minutes is to 28 minutes. That gives us a ratio of 8:7. 32 is to 28 is the ratio of 8:7. Now in the next step, we have to draw a line from the object, in our case, the hook head lighthouse, the line should be drawn in such a way that it is clear of all the three bearing lines, OX, OY, and OZ. It should be clear of the three bearing lines, and also the three bearing lines should lie on the same side or on one side of the line which we draw. So let's draw a line from point O. You can see a line is drawn from the lighthouse, Hookhead lighthouse, from point O, and it is drawn in such a way that all the three bearing lines are clear of this line, and all the three bearing lines lie on the same side of the line which we have drawn. So beta, any doubt up to here in the plotting?
So the line which we'll draw will be perpendicular to the middle bearing?
You can draw it perpendicular to the middle bearing also. In fact, many of the books, they recommend that it should be perpendicular to the middle bearing. But even if it is not perpendicular, it will still do the job. You can still get your correct answer, even if it is not perpendicular. Important thing is that it should be clear of the three bearings, and all the three bearings should lie on one side of it.
Okay, sir.
Okay, so shall we move ahead with? Right, let's move. Now on this line, which we have just now drawn, passing from the lighthouse, we have to measure convenient distances on either side of the object, on either side of hook head light or either side of O. The distances should be measured or marked in the same ratio what we obtained between the first and second bearing and the second and third bearing. We obtained a ratio of 8:7. So we have to measure convenient distances on this line on either side of object O in the same ratio, that is 8:7. So what I'm doing here is I open up my compass equal to 8 nautical miles, place my compass on the hook head lighthouse, and make an arc to cut this line. You can see the arc on the plot now. The radius of this arc is 8 miles, 8 nautical miles, and the center of this arc is the hook head lighthouse. Now the point where this arc cuts the line, let's name this as A. Now I open up my compass equal to 7 nautical miles. Center that compass, place that compass on the hook head lighthouse and make another arc now on the opposite side, on the side of the third bearing line, and cut this line. You can see the arc is drawn here on the chart, and it cuts the line at point B. So you can now see that the ratio of OA to OB is 8:7, and this ratio is exactly same as the ratio of time intervals between OX and OY and OY and OZ. The time interval between XY and YZ were having a ratio of 8:7, and we have the similar ratio marked on this particular line. I'm repeating once again. We have to measure convenient distances on this particular line on either side of the lighthouse or either side of the object O in the same ratio as we had obtained earlier between the first and second bearing, second and third bearing. And when we do this, we obtain point A. Point A is on the side of the first bearing line, and we obtain point B, which is on the side of the third bearing line. Any doubt in your mind, beta, up to here?
Nice, sir.
No, sir.
No.
Okay, beta, great. Let's proceed. Now, once we have obtained these points A and B, now in the next step, we draw a line passing from both these points, point A and point B, which is parallel to my middle bearing. My middle bearing is OY. In this case, the middle bearing was 0, 0, 0. So I'm going to draw a line from point A, which is parallel to my middle bearing. Let's plot it on the chart. You can see this line now passing from point A parallel to my middle bearing. Now this line cuts my first bearing line, first PL, OX at this particular point. Let's name this point as C. Now likewise, I draw a parallel line passing from point B. So this line is passing from point B and is parallel to my middle PL, my middle bearing OY. And this line which I have drawn, the parallel line, it cuts my third PL, the OZPL at this particular point. Let's name this point as D point. So we can see the C and D points marked on the chart on our plot. Now in the next step, we join these 2 points C and D. So you can see this green color line on the chart joining these 2 points C and D. This line CD which we have on our plot now gives us the course made good. Course made good is represented by double arrows. So you see the double arrows coming up on this line. We can now place our parallel ruler to this line and read off the course made good from the compass rose. The course made good comes out to be 078 degrees. Now in the next step, from point C, we construct a course, speed and current vector triangle for the time interval between the first bearing line OX and the last bearing line OZ. In our case, the time interval between the first PL OX and the last PL OZ is 1 hour. So we will be making a course, speed and current vector triangle for 1 hour starting from point C. So we know our CTS, which is given to us in the question, is 070 degrees true. So from point C, I draw my CTS 070 degrees true. And since I am making this for 1 hour, I have an engine speed of 10 knots, which is given to me in the question. So in 1 hour, I will be covering up a engine distance of 10 miles. So this particular vector represents my CTS, which is 070, and the engine distance for 1 hour, which is 10 nautical miles. Now this point where the vector ends, let's mark this point as eco. And in the next step, Now at point E, I apply my current. Now in the question, the current in the area is setting 105 degrees true. So from point E, I mark my current in the direction of 105 degrees true. You can see the red color vector in the direction of 105 representing the current vector. Current vector is represented by triple arrows, 3 arrows. So let's label this vector with 3 arrows. Now wherever this vector goes and meets our course made good line, that is the green color line CD, let's mark that point as F. EF now represents the set and drift of the current for this particular duration. We have made this triangle for 1 hour, and the vector EF represents the set and drift of the current for this particular interval. Any doubt up to here, beta, in the plot?
No, sir.
Very good, beta. Great. Let's proceed then. Now, if you look at the third side of the triangle, the third side is CF. The third side of the triangle represents the course made good and the distance made good by the vessel in the same duration, that is for 1 hour. So side CF represents the course made good, which is 078, and the distance made good, which comes to 12 miles. This is the distance made good by the vessel in 1 hour. Side CE, which is the blue color side, represents the CTS vector with a duration of 1 hour, and side EF represents the set and drift vector, the current vector, again for a duration of 1 hour. Now you see, we were required to find out the CMG. CMG has been obtained from this plot. The line CD represents the direction of the CMG. We were required to find out the speed made good. Now we have the distance made good in 1 hour, which comes to 12 miles. And fortunately, in this case, since the triangle is made for 1 hour, this is also our speed made good. So the speed made good of the ship is 12 knots. We were also required to find out the rate of the current. The rate of the current can be easily obtained from the magnitude or the length of vector EF. So since the triangle is for 1 hour, whatever length of the EF vector we obtain, the same will be the drift as well as the rate of the current. So these 3 items have been obtained: CMG, SMG, and rate of the current. Now in the next step, we will transfer our first bearing line, which is OX. Transfer the first bearing line OX to point F. We are applying the concept of running fix now. So we are transferring this line OX to point F. So we pick up our parallel ruler, align it with our first bearing line and transfer it to F. You can see the transferred position line now. The transferred position line is marked with double arrows. So you can see the double arrows coming up on the transferred PL. Now this PL has been transferred to the time of 1100 hours. The PL, initial PL which we had, OX, was for 1000 hours. We have applied a run for 1 hour. This triangle is for 1 hour duration. And the transferred PL which we see now is transferred to 1100 hours. So we have a transferred PL for 1100 hours marked by double arrows. We have a original position line, the third position line OZ, which is also for 1100 hours. So the point where the two intersect, this is the point where the two position lines intersect, marks our position at 1100 hours. Let's name this point as R, and this R point is our position at 1100 hours. So we have our 1100 fix, and we can read its latitude and longitude from the chart. Now from this 1100 fix, we draw our course made good vector in the reverse direction. If the vessel has reached point R at 1100 hours, then it must have traveled on the course made good line. So we draw the course made good line, course made good vector in the reverse direction from R. So you can see from point R, we have drawn the course made good in the reverse direction. Let's mark it off with the double arrows. Now this course made good, which we have drawn, cuts the first position line at this particular point. Let's name this as point P, Papa. This point P marks off our position, the vessel's position at 1000 hours. The course made good line which we have drawn in reverse from our 1100 fix cuts the bearing at 1032, the OY bearing line at this particular point. Let's name this point as Q, and this marks the position of the ship at the time of the middle bearing, that is at 1032. So we have the positions of the ship now. We have all the three positions. Position P is the position of the vessel at 1000 hours. Position Q is the position of the ship at 1032 hours. And position R is the fix of the ship at 1100 hours. All the three positions can now be read off from the plot and the latitude and longitude mentioned in our answer sheet. So all the items which were required have been obtained from the plot now. The position of the ship has been obtained at the time of all the three observations. The course made good is obtained, the speed made good is obtained, and the rate of the current is also obtained. So this completes our plot for a 3-point bearing question. Have a good look at the plot, beta. Let me know any doubts coming in your mind at any steps.
Sir, difference in this question and the running fix only in that in the running fix will be given both the direction and the rate of the current. If we in this question also if we'll given these two options, then directly this question will be solving by running fix. That's correct, sir?
That's right, beta. Running fix में बस as you rightly said, the only difference is कि हमें वो करंट का रेट भी बता देंगे. यहाँ पे आप देखो उन्होंने हमें करंट का सेट ही बताया है, रेट नहीं बताया है. So if they tell us the rate also, then it will be a simple running fix question.
Sir, if we transfer the third bearing line at 1100 like OZ to point F, and wherever it cuts the OC, can we get the position of 1000 hours?
Beta, ask again once. You are transferring the third PL to which point?
We are transferring the third PL to point F, and wherever it will cut OC, the first bearing line, that will be the 1000 hour position, I guess.
नहीं बेटा, नहीं. आप देखो ध्यान से. जो CF है बेटा, Charlie Foxtrot, CF is our course made good vector for 1 hour duration, right?
Yes, sir.
अगर आपको 1100 PL को reverse run लगाना है to 1000 hours, let us say you want to do that. It is not recommended, but let us assume कि आपके माइंड में आ गया कि मुझे 1100 को 1000 आवर्स पे लेके जाना है, तो आपको ये जो CF वेक्टर है, चार्ली फॉक्सट्रॉट वेक्टर है, इसको थर्ड PL पे किसी भी पॉइंट पे लगाना होगा. So if you want to take it back, you have to apply the Charlie Foxtrot vector. Then if you transfer it or apply the reverse run, it will cut the first PL at point P. It will give you your initial fix at 1000. Then it will happen.
Okay. But sir, how to apply this CF vector to? We can skip it or leave it. But how we will apply this vector to third bearing line?
Okay. हम ऐसा करते नहीं हैं. चार्ट वर्क में किसी भी क्वेश्चन में हमारी जो नॉर्मल टेंडेंसी रहती है, द यूजुअल टेंडेंसी, ये है कि पुरानी वाली PL को सबसे रीसेंट टाइम पे शिफ्ट किया जाए. So that is why you see we transferred the 1000 PL to the latest time, that is 1100. हमेशा हम चार्ट वर्क में ऐसा ही करते हैं. Reverse run is applied very rarely, only if it is asked to us in the question, then only we apply the reverse run, otherwise no. Okay, that is the first thing. बाकी as far as इसको लगाना कैसे है, लगाना तो बहुत आसान है बेटा. आपको CF की डायरेक्शन और मैग्नीट्यूड दोनों पता चल गए, करेक्ट, once you make this triangle.
Yes, sir.
अब आप कोई भी पॉइंट पिक कर लो अपनी थर्ड PL पे और रिवर्स डायरेक्शन में यही डायरेक्शन और मैग्नीट्यूड को अप्लाई कर दो, रिवर्स रन अप्लाई हो जाएगा.
Okay. Yes, sir. Yeah, हाँ एक बार किया याद आ गया.
Okay, but it is not recommended. It is always recommended that you transfer a old PL to the latest time.
Okay, sir. Okay.
Okay, right. और बताओ
सर इस
बेटा.
क्वेश्चन
और
में सर इस क्वेश्चन में रनिंग फिक्स 3 पॉइंट बेरिंग में वेरिएशंस आते हैं क्या सर, या ये नॉर्मल रहता है?
सिर्फ एक ही वेरिएशन आ सकता है बेटा. वो वेरिएशन ये है, इंस्टेड ऑफ द सेट ऑफ द करंट दे में गिव यू द ड्रिफ्ट. जैसे इस क्वेश्चन में उन्होंने हमें करंट का सेट दिया है 105, राइट. ये क्वेश्चन ऐसे भी बन सकता है कि वो आपको बताएं that the drift of the current was 3 miles. They don't give you the set, they give you the drift. Okay, variation समझ में आ गया बेटा?
हाँ यस सर.
अब अगर
जैसे
ये
105 दे रखा है इसमें, उसमें
हाँ,
3 नोट
इसमें
दे दिया, उसमें ये दिया नहीं है. ओके
right. So can you tell me now how will it be done?
Sir,
So
at the
हमें
E
मालूम
point, we cut it the arc, I think, yes, sir, on the CMG.
हाँ, so बेटा हम पहले तो अपना CTS ड्रॉ करेंगे as usual. चार्ली इको CE हमने ड्रॉ किया था. Now from point eco we will place our compass centered at E, open it up equal to the drift which is given. Let's say for example 3 mile drift अगर हमें दिया है, तो हम compass को 3 mile open करेंगे centered at point eco and we will draw the arc. So wherever it cuts the CMG line, that will be our F point and our triangle will get completed.
ओके सर. देन अगेन फर्स्ट PL को ट्रांसफर कर दो, सेम स्टैंडर्ड प्रोसीजर. ओके
Right, that's right.
ओके सर.
Okay beta, great. So procedure is clear beta. Shall we move ahead?
यस सर.
Okay, all right. Okay, now beta, the next calculation which we have is sighting an object right ahead at a certain distance with current but without leeway. So let me explain to you what this question is, what all information is given, and how do we solve it. So let's see. So our next topic is sight an object right ahead at a certain distance with current prevalent in the area but without any leeway. So let's see how do we solve this type of question. As you see, we need to sight a particular object, most of the time a particular lighthouse. It should be right ahead at a given distance of. The lighthouse should be sighted right ahead at a given distance of, and there is some current in that area. So we need to find out our CTS. The CTS is not known to us, so that the lighthouse is right ahead at the given distance. Let's first see what all information or data items which are provided in this type of question. They will tell us the initial position, observed position or fix of the ship. The engine speed is given to us. A reference object which needs to be sighted right ahead is given to us. At what distance the object should be right ahead is also given, and the direction and rate of the current, set and rate of the current is also given to us. So this is what all is provided, and what we are required to find out is the course to steer. So let's try to plot this information onto the chart. We have the chart on our screen. So let's first plot our initial position. You can see the initial position marked by this green color circle. Let's name it as A. This is our initial position. Let's identify the object which we are required to keep right ahead. In this particular example, we are assuming that this hook head lighthouse is to be sighted right ahead at a given distance. So let's name the object as O. Now the set and rate of the current which is prevalent in the area is also given to us. All these items are provided. We are required to find out the course to steer to sight the object right ahead at a given distance d. So let's now see how do we go about this question. Now, first of all, in the first step, we should be clear in our mind that this is also a little different type of question. Different in a way because the questions which we have done till now, we had the information given to us in the question. We plotted that information onto the chart and got our answer. Now, in this particular question, you cannot find out how to do this or the method to do this question by thinking out. So let us say if you get this question first time in your exam, it will be difficult to think about the procedure and then start the plotting. You need to know beforehand, before you start solving this question, that what is the method with which we should be solving it. So the method needs to be known beforehand. Once you know the method, you know the stepwise technique, you can follow it, and in the end you will be able to see that the technique which you followed is correct. So it is a typical question in a way that you need to know the procedure beforehand. Okay, right now we don't know it, but by the time we complete this, you will have the procedure known to you, and then you can follow it stepwise and solve it. So this is how it is different from the previous questions. So step number 1 in this question, we need to find out the time required to cover the given distance. Let us say they want us to have this lighthouse right ahead at 12 miles off. So we need to find out what is the time that our ship requires to cover this 12 miles distance using our engine speed. So let's assume our engine speed is also 12 knots. So we know that we require 1 hour to cover this distance. So this is the first step. Calculate the time required to cover the given distance d using the engine speed. Now, once you have that time known to you, we can proceed ahead. Once the time is known, we now have to calculate the drift of the current. You see, the set and rate of the current is given to us. We know the rate, but we need to calculate the drift of the current. So drift is to be calculated for how much time? For the same time which we have obtained just now. So we have just now found out the time which we need to cover the given distance using our engine speed. In the example which we took just now, it was 1 hour. So we need to find the drift of the current for this period only. So in this example, it was 1 hour. So whatever the drift of the current is for that 1 hour, that is what we need to calculate. So once we have the drift known to us, now we can start the plotting. So what we will do is, from the object O, in our case the Hookhead lighthouse, we are going to draw the current vector, that is the set and drift of the current, which we have just now calculated. The drift is for the time duration which we need to cover the distance using our engine speed. And we will plot that vector starting from the object, in this case the Hookhead lighthouse. So let's plot the current vector. I have plotted the direction of the current vector. The length is equal to the drift in the same time which we require to cover the distance. The current is marked with 3 arrows. So let's make this marking. You can see the current vector. The point where the current vector ends, let's name that point as Bravo. So you see on the plot, Oscar Bravo is the current vector. The duration of the vector is the time required for us to cover the given distance. Now in the you can see it here also. The set and drift is for the time which is required to cover the given distance with our engine speed. Now what we will do is we will join our initial position A in this case to the point where the current vector ends, that is point Bravo. So join alpha with Bravo. Let's plot it on the chart. So you have this line joining alpha to Bravo. This line, which we have just now plotted on the chart, is our course made good line. So right now a lot of questions will be coming in your mind. How is this our course made good line? The length of the current vector is for the time which is required to cover the given distance, but AB side could be of any length. So how this is our course made good? Let me explain the full procedure. It will become clear in your mind now. So AB is our course made good. Course made good is marked using double arrows, 2 arrows. So let's plot these 2 arrows here. You can see the 2 arrows plotted on the CMG. Now in the next step, we have to draw an arc. So pick up your compass and open up your compass equal to the distance of which we need to have from this object. The distance of at which this object should be right ahead of us. So open up your compass equal to that distance Keep your compass centered at the lighthouse, in this case, the hook headlight. So compass is centered at hook headlight. The compass is open, radius is equal to the distance at which it should be sighted right ahead. And now we are going to draw an arc so that the arc cuts our course made good line AB. So let's draw that arc. You can see the arc plotted on the chart now. This arc is centered at O, which is our object, and the radius of this arc is equal to the distance at which it should be sighted right ahead. So the point where the arc cuts our course made good line, let's name that point as Charlie. So you can see this Charlie point here. Now this Charlie point, or the position, is that point where the object is going to be sighted right ahead. When we are moving on the AB course made good track, it is at this particular point Charlie that the hook headlight will be sighted right ahead. Now, how is this possible? As I told you, line AB is our course made good line. And we have found out this point Charlie. Now, Charlie to Bravo, CB, is the distance made good in the calculated time, the time for which we drew the current vector, the time in which we will be covering up the distance at which we are required to sight the light right ahead. So this Charlie Bravo is the distance made good for that particular time. If required, we can also find out our speed made good. Once you have the Charlie Bravo distance made good, you have the time also in which this distance has been made good. So we can calculate the speed made good of the ship while moving on this track if it is required. Now, how is this Charlie Bravo the distance made good in this particular time? For this, let's draw a line joining point C, the Charlie point, with our object O, which is the hook headlight house. So let's join these two and mark this line CO. This Charlie to Oscar is our course to steer. So let's mark it with a single arrow. You see the single arrow being marked here. So Charlie to Oscar is our course to steer. Oscar to Bravo is the set and drift of the current. And Charlie to Bravo is the distance made good and the course made good. In fact, this triangle which you see, Oscar, Bravo, Charlie. So OBC, Oscar, Bravo, Charlie triangle. All the three vectors are for the same duration. That is the time required to cover this distance off from the lighthouse. So Charlie to Oscar, you can see it here on the chart, is the distance off at which the light is to be sighted. Remember, this arc was drawn with a radius equal to this distance off. And if you see this triangle OBC, Oscar, Bravo, Charlie, the duration of all the vectors, or the duration of the course distance current triangle, that is the OBC triangle, is for the time required to cover the given distance using our engine speed. Let us say if distance was 12 miles and our engine speed was also 12 knots, then this triangle is for 1 hour. So Charlie to Oscar is the CTS and engine distance for 1 hour. Oscar to Bravo is the set and drift of the current for 1 hour. Remember, Oscar Bravo drift was calculated basis this particular time only. And obviously, when Charlie to Oscar and Oscar to Bravo are for the 1 hour duration, then the third vector, that is Charlie Bravo, the green color course made good vector, will also be for the same duration. So now you can see why did we follow this particular method. Now everything falls in place. It becomes clear why these steps have been calculated or marked in this particular way. So that is the special thing about this particular question. You will not come to know beforehand why these steps are being taken. But once the plot is completed and you look at the plot, everything falls into place and it becomes clear that this plot which we have made is for the given time duration. And you see at point C, when the ship is at point C, the heading will be in the direction of CTS, course steered, and it is pointing right into the lighthouse. So hook head light is going to be right ahead when the ship is at C point, the Charlie point. However, the track on which the ship is actually moving is the green color track. That is the course made good track. So ship will be proceeding from Alpha to Charlie and then Charlie to Bravo over the ground. But at point Charlie, the hook head lighthouse will be right ahead. Now, before you reach at point Charlie, you are somewhere in between Alpha to Charlie. This hook head lighthouse will be on your starboard bow, at some place on your starboard bow. So at point C, it will be exactly right ahead. And when you cross point C and you are somewhere between Charlie to Bravo, you will see this hook head lighthouse crossing over to the port bow.
सर ये टाइम ट्रायंगल उतने टाइम के लिए ही बनेगा जितने माइल्स हमने उसको मतलब राइट हेड पे देखना है जितने माइल ऑफ
राइट बेटा, दैट इज राइट। ये जो ट्रायंगल है ये हम एग्जैक्टली उसी ड्यूरेशन के लिए बनाएंगे जितना डिस्टेंस ऑफ हमें दिया गया है, फॉर दैट मच डिस्टेंस, टाइम टू कवर दैट मच डिस्टेंस।
ओके सर, थैंक यू
सर। जैसे क्वेश्चन के अंदर में जब इनिशियली हमने स्टार्ट किया, हमें पोजीशन ए मालूम थी एंड हमें फिर हमें जितना माइल ऑफ बोला, सपोज 12 माइल्स ऑफ बोला, तो सर ये ओबी का सर ये डायरेक्शन तो मालूम है, ओबी जो करंट है, लेकिन सर ड्रिफ्ट कैसे मालूम पड़ा सर हमें, मतलब
ड्रिफ्ट इज गिवन बेटा इन दीस क्वेश्चंस, द सेट एंड रेट ऑफ द करंट इज गिवन टू अस।
ओके, दोनों मालूम है। तो हमने ओबी हमने वो कितने टाइम के लिए सर, मतलब कितना कट मारना, ये नहीं मालूम पड़ा ना, कैसे मालूम पड़ेगा? ओके,
मैं बताता हूँ। देखो इस क्वेश्चन में उन्होंने हमें डिस्टेंस ऑफ तो बताया है कि इतने डिस्टेंस पे लाइट हाउस राइट अहेड होना चाहिए, करेक्ट?
यस सर।
हमने ये कैलकुलेट किया हाउ मच टाइम वी रिक्वायर टू कवर दैट डिस्टेंस। हमें अपनी इंजन स्पीड पता है, हमने वो टाइम निकाल लिया। वी कैन फाइंड दैट।
कौन सा डिस्टेंस सर, कौन सा डिस्टेंस?
द डिस्टेंस ऑफ फ्रॉम द लाइट हाउस व्हेन इट शुड बी राइट अहेड,
मतलब ए टू सी। ए टू सी?
नो 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 नो, ओ टू सी बेटा। डिस्टेंस फ्रॉम द लाइट हाउस व्हेन इट इज राइट अहेड।
वो तो 12 माइल्स दे रखा है ना सर?
हाँ ठीक है बेटा, उसी 12 माइल्स के लिए अगर हम इसे 12 माइल्स अज्यूम करते हैं, हमने पता किया कि हाउ मच टाइम वी रिक्वायर टू कवर दैट 12 माइल्स।
अच्छा, हमारी इंजन स्पीड से? ओके ओके,
यस राइट, वो टाइम पता कर सकते हैं।
हाँ हाँ,
उतने ही टाइम के लिए ये पूरी ट्रायंगल बनेगी। करंट वेक्टर भी उतने ही टाइम का होगा, सीटीएस वेक्टर भी उतने ही टाइम का होगा, सीएमजी वेक्टर भी उतने ही टाइम का होगा।
तो इसमें आपने इंजन स्पीड आपने 12 नॉट्स लिया ना?
यू कैन अज्यूम, मैंने इसमें कोई क्वेश्चन नहीं दिया है आपको, आई हैव जस्ट एक्सप्लेन्ड द प्रोसीजर, सो यू कैन अज्यूम एनी डिस्टेंस।
क्योंकि अगर आपने स्टार्टिंग में अगर ये 12 माइल्स हमने ऑफ भी लिया है एंड स्पीड सपोज हमने एक्स ले लिया सर, तो जो ओबी हमारा 180 आया है ओबी, वो 1 घंटे के लिए आया, तो स्टार्टिंग में अपने स्पीड भी 12 माइल्स ले लेना, वरना छोटा होता। अगर स्पीड हमारी कम होती तो वो छोटा होता।
दैट्स राइट बेटा, दैट्स राइट। अगर हमारी 12 नॉट की स्पीड है और डिस्टेंस ऑफ भी 12 माइल्स है तो ये 1 घंटे की ट्रायंगल बनेगी. OB वेक्टर करंट वेक्टर विल बी आल्सो फॉर 1 आवर ड्यूरेशन.
अगर ये 12 माइल्स है लेकिन हमारी स्पीड सपोज 6 माइल्स है तो ये ट्रायंगल आधे घंटे की बनेगी या 1 घंटे कितने की?
अगर हमें डिस्टेंस ऑफ उन्होंने 6 माइल दे रखा है और हमारी स्पीड 12 नॉट्स की है तो इसका
जी.
मतलब हम आधे घंटे में उसे कवर कर सकते हैं. देन दिस फुल कंप्लीट ट्रायंगल विल बी फॉर हाफ एन आवर.
सो बेसिकली ये हमें डिस्टेंस ऑफ कितना मिनट में करेंगे उसका ट्रायंगल बनेगा ये.
Yes, that is right, beta. That's right.
चाहे 40 मिनट हो चाहे 20 मिनट हो.
Yes, it can be any duration. It depends upon कि हमें कितना डिस्टेंस ऑफ उन्होंने दिया है और हमारी स्पीड क्या है.
ठीक है सर.
ओके, और बताओ बेटा, और क्या डाउट आ रहा है?
सर कोई क्वेश्चन है क्या सर आपके पास, ऐसा सॉल्व्ड क्वेश्चन है क्या सर कोई?
बेटा इसका सॉल्व क्वेश्चन तो नहीं है. यू कैन गेट इट फ्रॉम पास पेपर्स इफ यू वांट. मैं आपको एक क्वेश्चन भेज दूंगा. लेट मी सी, असाइनमेंट में शायद कोई सॉल्व क्वेश्चन होगा. लेट मी चेक अप बेटा. गिव मी अ मिनट, अभी चेक कर लेता हूँ मैं. Oh, we are done for the time. So anyway, मैं आपको असाइनमेंट में चेक करके बता दूंगा बेटा. If we have any question on this, I think there should be a question.
जी सर. एंड सर जो सुबह आपने जो क्वेश्चन जैसे कि लास्ट असाइनमेंट में दिए थे ना सर, लास्ट वाला क्वेश्चन था बेली कॉटन वाला, उसमें विजिबिलिटी 5 माइल्स की दी थी. तो सर उसके अंदर जो ये नॉमिनल रेंज है सर, एक 22 दे रखी है, 18 दे रखी है सर, वो कौन सी वाली लेंगे? मैंने दूसरी ले ली थी, आंसर गलत आया, लेकिन कैसे लेंगे?
ओके बेटा, देखो 22 और 18 जो दे रखी है, दैट इज बिकॉज हमारी जो लाइट है इट इज वाइट एंड रेड. 2 सेक्टर है ना बेटा.
हाँ जी.
तो आप चेक करो कि हमारा जो शिप है वो कौन से सेक्टर में है.
अच्छा अच्छा, ठीक है सर.
विच एवर सेक्टर इट इज इन, तो वही लाइट हमें दिखाई देगी ना.
यस सर.
तो उसी की रेंज हम लेंगे. सो आई थिंक इट इज इन द वाइट सेक्टर. सो वाइट सेक्टर वाली रेंज से ही हम PLR निकालेंगे.
ओके.
वाइट सेक्टर 22 लेंगे सर हम.
राइट बेटा, दैट्स राइट.
ओके सर.
सर उसी सेम क्वेश्चन में एक डाउट और था कि जो PL आई थी इंटरसेप्ट के बाद, तो जहां पे ITP दे रखा था वहां से रन लगाएंगे कि सर रैंडम पॉइंट से उस PL पे रन लगा देंगे?
देखो बेटा, एज फार एज ट्रांसफरिंग इज कंसर्न, हम कहीं भी किसी भी पॉइंट पे रन अप्लाई कर सकते हैं, बट रिकमेंडेड होता है कि आप ITP से ही उसे लगाओ. और ऐसा नहीं है कि अगर किसी ने ITP को छोड़ के उसके आसपास किसी और पॉइंट पे लगाया तो गलत हो जाएगा. नहीं, इट विल स्टिल बी करेक्ट.
ओके सर. बिकॉज सर आपके सॉल्यूशन में वो ITP से नहीं था, इसलिए जस्ट कंफर्म करना है.
It is recommended that you apply it from the ITP.
ओके सर.
एंड सर स्टैगर्ड ऑब्जर्वेशन में भी हम लोग नॉर्मली ITP या फिर अगर पोजीशन क्वेश्चन में दिया DR से अप्लाई करना है तो वहीं से अप्लाई करते हैं ना रन भी?
राइट बेटा, राइट. इट इज ऑलवेज रिकमेंडेड, कोई भी PL अगर आप ट्रांसफर कर रहे हो, स्पेशली सेलेस्टियल PL, तो जो रेफरेंस पॉइंट आता है उस सेलेस्टियल PL का, इन केस ऑफ इंटरसेप्ट इट विल बी ITP, in case of long bichrone it will be observe long and DR lat. Okay, in case of X meridian it will be observe lat and DR long. We usually recommend applying the run on that particular point, so because that is the closest point, which means the most accurate point, the most probable position of the ship. So उसी पे हम run लगाते हैं. That gives us a good idea. But as far as geometry is concerned, कहीं पर भी अगर आप रन को अप्लाई करते हो, you will still get the same transferred PL.
Sir, if we'll apply the run on the ITP in this last question, we used to transfer the full T, not only the PL. That's correct, or?
No, I don't get your doubt, beta. Can you ask again?
Sir, like I have applied the run on just, I took one point on the PL and I applied the run, and then I just only transfer that PL to that circle, and in that case I'll apply to this DR position. Then I have to transfer this only PL or even this intercept plus PL, like staggered observations.
ओके, सो यू आर आस्किंग कि अगर हम डीआर पोजीशन पे रन अप्लाई करते हैं तो फिर कैसे ट्रांसफर होगा, राइट?
Yeah, that's correct.
ओके, इन दिस केस इट इज नॉट रिकमेंडेड, बिकॉज इस केस में हम अगर डीआर पे रन अप्लाई करते हैं द मेथड विल बिकम लिटिल लॉन्गर। अगर आप डीआर पे रन अप्लाई करते हो तो जो नया पॉइंट आपको मिलेगा, ट्रांसफर्ड पॉइंट जो आपको मिलेगा, उस पर आपको फिर से इंटरसेप्ट अप्लाई करना पड़ेगा। सो इट विल मेक इट अननेसेसरली लेंदी, सो दैट्स व्हाई नॉट रिकमेंडेड।
Yeah, likewise, sir, in the question I used as a normal running fix, I took a point from the PL itself, like a normal PL. But my question was, even if I'll apply this run from the DR, then again I have to apply the intercept towards 3 mile, then cut a PL, and then wherever it cuts on the circle, that's my position of the second time.
That is right, beta. If you apply the run on the DR, you will have to plot the intercept again, and then you will get the transferred PL.
Understood, sir.
सर जो अभी हमने राइट हेड वाला क्वेश्चन किया है सर, राइट हेड वाला क्वेश्चन किया है सर, जस्ट टू कंफर्म मैं वापस रिपीट कर रहा हूँ सर एक चीज, ठीक है सर? जितना माइल्स हमें ऑफ बोला है, हम हमारी जो भी इंजन स्पीड भले ही हो, उसके हिसाब से हम उतना माइल्स कितना टाइम में करेगा उतने का ही सेट ड्रिफ्ट मार लेंगे एंड उतना ही वो करेंगे।
बिल्कुल सही है बेटा, तुम बिल्कुल ठीक बोल रहे हो।
ओके, थैंक यू सर।
सर एक क्वेश्चन था सर, अभी
बोलो।
चैट में डाला सर, इसमें क्वेश्चन नंबर 8 है सर।
ओके बेटा, हम लोग अभी दूसरे लेक्चर में स्ट्रेच कर रहे हैं, तो इसे अगले सेशन में देख लें। मेरा लंच के बाद भी आपके साथ एक सेशन है, करेक्ट?
ठीक है सर, ठीक है, ओके
है ना? सो जस्ट रिमाइंड मी दैट टाइम, हम लोग इसको उस लेक्चर में देख लेंगे, बिकॉज नेक्स्ट लेक्चर इज नॉट माइन। सो है ना? सो लेट्स कीप इट फॉर द नेक्स्ट लेक्चर। और भी अगर कोई डाउट होंगे, यू कैन कीप देम रेडी, अगले लेक्चर में हम उनको डिस्कस कर लेंगे।
राइट,
ओके, so see you in the next lecture then beta. Bye bye.